In the process of checking out the or ohming out all the coils, which is the first thing you should always do on any chassis, ohm out all your coils first before you change anything or do anything. And in the process of checking all the coils, which includes the primary and secondary of the power transformer, I found that from the center tap to the upper half of the power transformer secondary was open. The bottom half's okay, up to the plate of the 80 tube. This is the 80 tube right here, the two plates. This one is open. So I went ahead and removed the power transformer, and this is what I found. I found this big old burn spot, and that's where our open has occurred. But then I went ahead and took my pocket knife. I blew out a lot of the old black ash that was down there and dug around very, very carefully, very gently with my pocket knife. And I found that, look, see that right there at the tip of the knife? Let me see if I can get a little closer here. See that very thin wire right there? I managed to scrape some of the, that originally was an enamel coated wire. And that's part of the primary or the secondary winding, as it turns out, of this transformer. Fortunately for us, it's out near the surface, as opposed to being, way back here in the depths of the transformer. So I took my knife very carefully. I wasn't sure exactly, what that wire went to, but I went ahead and very gently scraped off some of that enamel until I got down to the shiny part of the copper. And when I ohmed it out, this is what I found. I show continuity now between that wire right there and the center tap. This right here. If I can solder a wire onto that very thin wire right there and then bring it across and down through here, down through this hole. If I can then get continuity on both sides of that transformer, top and bottom, I can, if that's the case, I can, put a whole bunch of liquid tape in there and really seal it up real good. And I can go ahead and clip off this wire here, insulate it, and we don't even need to use it. We'll have a brand new wire coming out. Now initially I'm going to go ahead and I'm not going to solder a 22 gauge standard hookup wire to it. No, that would be kind of rough to deal with. What I'm going to do is solder on a 22 gauge enamel, or let me see, yeah, 22 gauge would be about right. I'll solder on 22 gauge. I could even use 24 gauge enamel coated wire. And I'll bring it out here like this, and then I'll go ahead and hook on a piece of hookup wire and run it down through here and on out. Then I can coat the entire thing with liquid tape. That's one way of doing it. Or I could even use a 24 gauge wire, which would be even thinner. But either way, I'm hoping everything checks out when I'm done. If that, sometimes you get lucky, which I think I have right here. I just got lucky that the burn spot was near the surface. Let me see. Come on now. Get a little clearer. The burn spot was near the surface, and that little thin wire down in there is, let me see if that little thin wire right there, that thing right there, might save the day on this transformer. We're going to find out. Now the first thing we're going to do is we're going to tin that wire. We've got to get some solder on that wire. We can't just stick the other wire down in there and expect them to solder together. We've got to get some tin solder on that wire, and hopefully I'll be able to do that. I'm just going to heat it with the old soldering iron in one hand and just kind of touch it with the solder in the other, and hope I can get a nice coating on that wire. So wish me luck on that one. It's not going to be easy. So far so good. I was able to tin the wire. What I did was I took this screwdriver right here and I held it up underneath like so. Let me get over here where the screwdriver is. Where are you, buddy? Okay, I gently held it up underneath like so to support the wire. Not very much pressure, just enough. Then I took my pocket knife and scraped the top to get the enamel coating off of it. Okay, you got to get that enamel insulation off. Gently scrape the top, gently. It's not one of these things, you don't want to gorilla the thing. Gently scrape the top, then I turn the blade around and kind of gently scrape the bottom as much as I could, because remember the screwdriver is underneath there, supporting it. Then I went ahead and hit it with the soldering iron and solder, and as you can see, we have a tinning on the wire. I've taken a 24 gauge wire here, enamel coated wire, and I stripped the very end of it down here so I can use it, you know, bare wire to take voltage readings and resistance readings once I get everything hooked up. And the idea here is to wrap the other end around that little piece of thin wire in the transformer, just like you see it's wrapped around this paper clip. Now it can be done if I don't shake too much. I guess I'll just have to coordinate my shakes. But what I'll be doing is wrapping it around that little wire, if I can find it here, that little wire right there. Where the heck is my little pointer? Let me get this down here. There we go. That little wire right there. I'm going to wrap that wire around there just like you see it around the paper clip. But first I got to tin it, so I'll have to remove it and then we'll tin it. That's our next step. The wire has been tinned and it has been wrapped around the tiny little wire. It's not touching this big piece. It looks like it is, but it's not. There's pretty good space there between the two. So now what I have to do is take a little bit of flux and kind of paint it on there. Cover the two wires up. And then I'm using a 25 watt iron this time, not my normal 60 watt. I found a little 25 watt iron in a flea market, I guess about 2 years ago. I think I paid $1.50 for it, this little skinny thing here. Matter of fact, I think it might have come from maybe a wood burning kit or something. It's not in the best of shape, but you know, for $1.50, I went in there looking for a low wattage iron that day, and there that thing sat. So we're going to go ahead and put the flux on there, and then we're going to just kind of stick this little iron down in there and get that solder melted and get the two together. It should work. Stand by to stand by. Alright, the flux is on there. I just used regular old paste flux in a round can. This is what it looks like right here. Let me back up a little bit too close. Just regular old can of paste flux. It's a Lennox all-purpose, general purpose paste flux. Now we'll see what happens. Well, she's soldering on very securely and without any major damage. Real good. Now we have to take some resistance readings. So let's go ahead and back up here. First thing we're going to do, let me get a pencil here. Okay, the first thing we're going to do is we'll measure from the wire that went to this place, or this would be the new wire we just soldered in. We'll measure from the new wire and see if it goes down through the coil and comes around and comes out to the other end of the wire. So we're going to measure the entire coil first. Then we'll see if we get about half of that amount to the center tap. Okay, I've already got one lead with the wire wrapped around it. Let me get the other one if I can figure out where it went. Here we go. Alright, we're going to measure the entire coil now from the one we put in to the opposite end. Now both of these would be hooking again to the plates on the 80 tube. Hopefully it's good. No, we're not getting anything here. Oh yes we are. 238. Yes, yes. Now let's measure from here to the center tap. Let me set that wire up. I now have the black wire connected to the center tap. Now we're going to go ahead and check from the wire we installed to the center tap and see what we get. We should get about half of 240 or somewhere. And now keep in mind we lost a lot of wire, a lot of coils up here where that thing was burned. We probably lost an outer, I don't know, it looks like it could be almost an eighth of an inch of wire, maybe a little bit more, I don't know. We're just trying to get it functional right now so I can get the radio to play. If it doesn't play exactly perfect because of this, that's okay. I don't have a problem with that. This is a 1931 unit, and we just have to live with what we got. Because you think I'm going to find another transformer like this? Not going to happen, guys. We have to go with what we got. We got real lucky finding that broken wire right there, that burn spot. And I'll tell you why that burn spot was there to begin with. Why did that coil burn out right there? I'll tell you why later. Okay, here's our reading. 98 ohms. All right, we should have read about 120, but like I said, we did lose a few ohms because of the wire loss. Well, I'm happy with that. As far as I'm concerned, it's a success. And well, let me put it this way: it's a success because I was able to hook up a wire to it and get some resistance. The success comes when I hook the voltage to the primary. Now I'll be hooking that voltage to the black and white wire if I can find the stupid things. Here they are right here. This is where we'll hook our voltage to the primary out of my variac, okay? When I get it back on the bench there, we'll get it hooked up to the bench, and then we'll read the voltage across the secondary. Those of you who have watched my videos in the past saw me do this with another transformer. So if we get enough voltage out to operate the TV, I mean, shucks, I got that halo light thing on my brain here. Anyway, if we get enough voltage out of the transformer to operate the radio to the plates of the 80, I'll be a happy camper. And then we can go ahead and start putting all of our liquid tape in there and securing these wires. I'll cut this one now and get rid of it. That's the old wire that this one took the place of. So, all right, stand by again. Well, the old CRT from the Halo Light TV we're working on had to make way this morning. So I set it over on the kitchen table. That made wifey happy. Now we're going to go ahead and test our voltage out of the high voltage winding on the power transformer. So this looks pretty complicated. A bunch of wires run everything but everywhere, but it really isn't. It's pretty simple. Let me show you what we're doing so everybody's in tune. I took the right here, I plugged this power cord into my outlet that comes from the variac, okay? The variac feeds that outlet, so I can control the voltage going into the transformer. I just don't want to, plug it into the wall and slam it with some voltage. That might not be such a hot idea. There may be other places that are weak down in that transformer. I don't know. For all I know, this entire fix may last, 10 minutes, and that'd be the end of it. So, but it's been fun, just giving it the old college try here. Let me move this light down a little bit so it doesn't put so much of a glare. Okay, we've got our power cord plugged into there, which will be controlled by the variac, and it will control the voltage going to the primary. I have the power cord hooked in to the top and bottom of the primary, okay, which is, let me see, it would be these two right here. Okay, these two wires right here, a black and a white. All right, a black and a white. Then we're going to start bringing up the voltage, and when we do, I have the other multimeter. By the way, I'm monitoring the voltage coming out of that power socket with this setup right here. I don't want to go over. I'm not certain. I want to know exactly what the volts is coming out of there. I'll probably take it up to about maybe 117, 118, because I eventually, we're going to go ahead, eventually down the line when we work more on this chassis, we'll put a power resistor in there, which will cut it down to about 117 volts. I've got 124.5 coming out of our wall sockets. The next connection that I have made is, I have the multimeter connected. Come on, focus in, baby. I have the multimeter connected between pins 2 and 3. Which will give us the total output of the winding. And then once we get that, we'll switch it over to the to this winding right here that was previously open. This is the one we repaired, and we'll find out what kind of voltage we're getting out of that one, and which one how much voltage out of this one. Ideally it would be split in half, but if I'm getting 600 volts out, I should get like 300 and 300, but that's probably not going to happen. So let's get ready to go here. Well, I'm feeling pretty good already at 78.3 volts being fed into the primary of the transformer. We're getting 394 volts, 393 volts out of the secondary. So far, so good, okay? Let's take it up a little bit higher. Let's go up to say 90 volts or somewhere around in there and see what we get. This is really interesting. I'm glad I was able to do this. We're up to 454 volts at 90. My goodness, I think we might even have a repair here. I'm not going to say a repair. It wasn't a repair. We just made it functional again, okay? Let me see. Let's go ahead and take it up to 100. volts. Let's see what we get. 506. Not too shabby. I'm impressed. I'm impressed. We're looking for about 600 all total. Let's go up to 100 and oops, something's smoking. Shucks. I got a little bit of smoke here from something. That was not good. Ooh, I gotta look around in there. It may have further shorts down in there. I don't know. Well, she burnt off on us again, right here on the right hand side. However, I can see the stub down in there, so you know, maybe all is not lost yet. You know, you can see where it burned off right there. What a bummer. If I can maybe cut some of this paper out of here and get down to that stub, I might be able to still solder the two together and give it one more try. I'll try as many times as I can on this. Tell you what we're going to do. At least you've seen so far one way to do this. It may not be the right way, but it's my way. And we'll go ahead and wrap this video up here. Today I'll spend some time cutting away the paper, see if I can get to that stub. And there will be a part 2 to this, okay? So until then, this is John.